Hey there everyone, and welcome back again to the JavaScript test-driven development live stream. I'm Josh Justice, aka Coding It Wrong, and as always you can tell me afterwards if you think that I am in fact coding it wrong. So I'm back today and very excited to be doing some test-driven development. I tweeted about this earlier. It's been not a rough couple days at work, but I've just been dealing with some really challenging code that's stretching my brain. It's frustrating, I have to backtrack, I have to change things up. I was really hoping that this code at work would go faster, and it's just not been. It's been a slog. And as I've done it, it's reminded me why I love test-driven development and this mindset, this focus on small steps and keeping the test passing. This is what I've been falling back to at work as I've been making these changes, and things are hard to do is, okay, let me undo the changes, let me get the test passing, and then let me make a smaller step again and make this incremental progress to go forward. It is not fully easy. It's, some coding tasks are just hard, but it's helped. Taking these small steps has helped. And so I've been excited to get back into this exercise together today to get a real feel for this nice TDD process of taking these small steps. This kind of gets at why I do test-driven development and why I love to teach about it. Ever since I learned about testing, automated testing, my quality of life as a developer is so much better. I feel like I have a better work-life balance where I can go home and feel confident that the code's going to keep working and we're good to go. So if you're on the stream here or listening to this recording and you don't really care much about testing, I want to help you see how beneficial it can be. It doesn't just need to be, checking boxes. It can really help. And if you do care about testing, I want to help equip you with a mindset that's going to help. A way to think about your code and a way to think about your tests that whether you're writing the test first or not is going to help you to write these tests that are going to get you a lot of value. Before we jump in today, I want to do a quick plug for a free online book that I've written that I've mentioned before. It's called Outside-In Front-End Development. So if you're a React developer or a Vue.js developer, you may want to check this out. I talk about a front-end development approach, an outside-in TDD approach to front-end development. It's inspired by the book Growing Object-Oriented Software Guided by Tests. It covers agile practices in general as well as test-driven development for end-to-end test and for unit test and component test for your React and Vue.js component tests. There's a whole series of exercises, an extended exercise in React and in Vue.js, so you can choose one or the other depending on which one you go to. And I'm not trying to make any money off of this. You don't have to put in your email address to view it or anything. Again, this is just another resource I want to put out there to help people get the benefit from test-driven development that I've gotten myself. So check it out. We're going to jump back in today to the Roman numerals exercise. We made some progress on it last week, and we're going to pick it up where we left off and move on from there, and I'm excited about where it's going to go. Again, please, if you were live in the chat, please feel free to say hello. Would love to hear from you if you're online. If you're watching this recording afterwards, leave a comment. I would love to see that people are watching this video and getting benefit from it. Give me feedback, ask me questions, give me challenges. If you have something that you'd love to see me test drive or to know about how you might go about testing it, and maybe we could do it on the stream sometime. JCubed is back. Hello again. Glad you're here. Thanks for your support, fellow streamer Jeremiah. Hope it's okay for me to say your name. So thanks for joining. One thing that I wanted to share before I forget we go in, I noticed how repetitive my tests were getting as I wrote them, and I realized that I didn't have snippets set up to automatically populate them. And so I got those set up last time. I think they were on my work computer and I hadn't made it over to my personal computer. So they are now good to go. So we could say JIT for a jest test, and we get a nice test here. So let's go ahead and get our next test started. We want to convert 11 to xi. And we just hit tab, we're down in the body, and we can do JExpect to get an expect number to Roman numeral 11, tab to equal xi. So it's very nice. If you are in Atom, you can see how they work. Actually, I should just go right to the link because I stuck them up on a page, just snippets, and I'll post the bit.ly link in the chat. And I'll put it in the notes afterwards as well. So this is where my just snippets are. You can see we've got just a snippet for an async test because it's kind of tedious to go back and add that async keyword afterwards. For a describe block, for an it block, and for an expectation. Pretty simple, pretty straightforward. I'm sure there's plenty of others you could add in, but it just saves a little bit of time. So I wanted to put that out there. Again, if you just go to bit.ly/jest-snippets. You'll be able to get these for Atom. You can adapt them if you use a different editor as well. All right, so let's jump in here. As you can see from our test output here, we got cases 1 through 10 passing last time for our Roman numeral converter, converting from numbers to Roman numerals. And I'm going to wait to save this 11 case. Where we ended up in the code is we had this series of conditional branches here, and we started to see this pattern where there was a 5 threshold and a 10 threshold. So we extracted these constants here, and then we saw this repetition here where if the number was greater than a 10 threshold minus 1 or greater than a 5 threshold minus 1, we took certain branches here, and then if it was equal to the thing minus 1, then you put in a 1 digit there. So some repetition here across the 10 case and across the 5 case. And I think if we just take it just a little bit further, we're going to see the repetition even more clearly, and then we're going to be able to pull out another abstraction as well. We also have a to-do here where we don't love the fact that these constants actually mention the values, the 5 threshold and the 10 threshold. I'll bet you this is going to turn into a loop at some point, and that's going to prepare us for kind of moving all the way down the line for this Roman numerals case. And I will say again, if you want to get to this exercise, where's the link to the exercise? Well, yeah, what is it here? Well, I'll just paste the full link in the chat. Oh yeah, no, there it is. I posted it earlier. bit.ly JS Roman numerals. So you can go to that link there, JS-TDD-numerals, and this will pull up the exercise. The repo, well, this is the README describing the exercise with the link to the original exercise at codingdojo.org. Thanks again, Coding Dojo, for providing this exercise, this traditional TDD exercise. And if you go into the repo, you can download the code in the current state. You could try it out locally. If you're watching this later, you could pause the video, give these exercises a try yourself a bit, and then start the video again and see kind of where I've taken it, if it's similar or different from yours. All right, so let's get some exercising going here. We've got our 11 case here that I think is going to drive us out to more of a pattern that we can kind of remove duplication from. So let's start our TDD cycle, red-green refactor. First, we want to add a new test and watch it fail. So we're going to save with this 11 test, and sure enough here it fails. We say we expected number to Roman numeral of 11 to give us xi, but it gave us x instead. So I have tried to not think ahead, so I'm reorienting myself to the code here today. So if the number is greater than the 10 threshold minus 1, so it's greater than 9, so we go into here, and then if it is 9, well, it's not, and so we just add in x. So this is happening, and then we're just falling out the bottom of this function here, returning the 10. So I think we want to return the 11 here. And we could say if number is equal to, and we could say 11, but let's go ahead and say 10 threshold plus 1, numeral plus equals, and we can use the numeral 1. You know, we've already got the constant, so let's go ahead and use it. I think when I save this, this is going to make the test green. It's going to pass the xi case, the 11 case. And it does. All right, so do we want to refactor? We're starting to get very close to the pattern we see in the 5 branch here, but I want to let the test drive us there to the point of where we remove duplication there. So I don't see any refactoring to do now. We've got the red-green refactor is our sequence, and so I don't see refactoring that jumps out to me yet, so we're going to move on to the next test. Let's use our snippets. Converts 12 to xii. Just expect number to Roman numeral 12 to equal xii. Well, that was a lot faster when I practiced it and didn't feel the need to explain it as I went. All right, we're going to save this test. We get red. We expected xii, but we got x, and that's because in this conditional we added in, it was just a direct equals. So let's, now we could add in another case, but we're pretty sure we're going to need to do this here where if it's greater than or equal, we got this loop going. So let's just follow this pattern in the 5 threshold where we add potentially more than one I to it. If number is greater than the 10 threshold, then we're going to increase it by number to Roman numeral number minus the 10 threshold. So this should give us I in the 11th case, I in the 12th case, and actually handle future cases as well. We save, and it passes. And so this is great. Oh, I forgot to commit my 11 case. So let's go ahead and commit here. And I'll just bring up a little terminal at the bottom of my editor. I will sometimes use the terminal in the editor for transient stuff like committing, not too much lately, but I've just found with Atom, I just like to leave my tests and my application running in a separate terminal. That just ends up being a nice way to do it. So let's just review the commits here. Add handle 11 and 12 cases. So that's nice. That's good. So yeah, let's look at this duplication. We've gotten to green. Let's talk about refactoring. I think these two branches, the 10 branch and the 5 branch, are now identical. So let's see if that's the case. If number is greater than or equal to the threshold minus 1, then if it's equal to the threshold minus 1, add a 1. Then add the threshold's number, the corresponding character for the digit. And then if it's greater than the threshold, then we convert the remainder, what's remaining, into i's. And we recursively call number to Roman numeral and go from there. So these are now identical. And so I think we can remove this. I think we can put this into a function that we can recursively call. Not recursively call, I'm sorry. Yeah, a function that we call from within number to Roman numeral. Do I want to extract it like that? Is there a way? Yeah, now let's pull it out. So we can do here, maybe to do this in small steps, we could say numeral plus equals, and I don't know what to call this, but let's just call it a 10 threshold case. It's not a good name that's going to exist ongoing, but this is just temporary while we pull it out, and then we can see what name emerges. Number plus equals to, numeral plus equals to 10 threshold case. And it looks like we're going to need the number in there. So let's pull this out. We'll put it up above so we can see it, okay? Function 10 threshold case number. And this is plus equaling. Yeah, so extracting this is actually going to be a bit more finicky. I think what I'm going to do, again, is just kind of give a nested numeral here. Return numeral. And then we return that, and then it gets added on to the front there. So this is still hard-coded to handle the 10 threshold case, but I think we're going to be able to generalize it. Yeah, so let's save this and just see. Again, that comfort that I was talking about that I'm experiencing at work right now when the tests are green, I can do this refactoring in small steps, save, make sure it's still passing, and then I have confidence that I'm not wasting my time as I move forward to following steps. So let's see if I got this right. I save, and the test still passes. So that's great. And if I got it wrong, the test would not pass. If I comment this out, things don't work. And so I can see that these tests are ensuring that this is still working right. So what could we do to handle the 5 threshold case? Well, the only difference in there we found was the 5 threshold value and the character that's used. So let's change these into arguments. With more than really one argument, I want them to be named arguments instead. So let's just go ahead and change this instead. To take a named argument, and I'm going to save again to make sure, and the test will pass, so that's good. Well, let's not worry too much about the names because I think the name of this abstraction is going to emerge as we go. So let's just call this threshold is the 10 threshold. And when we get that threshold passed in, then we can put that in place of the 10 threshold here. We save, and now it's all passing. And I think we're going to need to pass in this character as well. So let's not think about it too much. Let's just call it Charmander, I think is what I was typing there. I've been watching a lot of Pokemon humorous stuff lately, even though I never played Pokemon myself. All right, so we got character, and Prettier is going to handle our wrapping. Incidentally, one of the nice things about using Prettier or other code auto formatters is as you're going through your code and making a lot of changes like you do in a test-driven development workflow and a refactoring workflow, Prettier will keep everything nicely formatted, so you don't need to expend mental effort doing the formatting yourself. It's really nice. We save the code here, and we see that it passes, and we're good to go. So let's, just to visualize this, to make sure this abstraction actually works for us, let's replace the 5 case as well. we got the, and instead of 10 threshold case, maybe we'll call it handle threshold case. Threshold. We'll handle that case. And so now let's handle this case down here as well. So it is now the, and let me not paste it yet. Let me not overwrite it. So now we want to have the 5 threshold as the point, the breakpoint that we're looking for, and the character uses the V instead, with the X. So I think this will work. I think we have successfully removed the duplication here between these cases. Save, and it still passes. So this is very exciting. So this refactoring has helped us. So can we do more? I think that the 10 threshold value and the character that goes with it, and the 5 threshold and the character goes with it, I think that's an object. I think that that is a configuration. Those two values go together, and so I think we want to create an object for that. So let's see how we can do that. To do small steps here, what we can do is instead of replacing these arguments, we can just add another named argument in their place. And so let's kind of just do this in small steps here. We could say 5 case. I don't know what to call it, so we'll call it a case here. We say a case has the threshold of 5 and a character of V. And let's say we have a 10 case. I truly feel just so helpless when it comes to naming here, but I do feel confident that we're going to get better as we go along of giving these better names. So it's interesting how that all works. So what I'm going to do now is pass in this case, 10 case, and in here pass in the case, 5 case. I think that I can save now and everything will still work because the case named argument isn't even being pulled out. It's not being used, but this again just ensures to me that I haven't broken anything yet. Then we'll call this a case, which might be a JavaScript keyword, which is not going to work. So let's not do that. Let's call it a config. I don't like that either, but we're going to get there. 5 config, 10 config, 5 config. Save. We do have a warning that config is not used. I do really like those ESLint warnings to let me know, but the fact that they don't break things, so I can keep going. So now let's pull out this config. I guess I could do it in line up top, but that seems like a little bit too much complexity. So let me just pull it out here. Threshold character equals config. And actually at this point, I won't need to change my other lines. I can just not use the threshold and character there. And I think that this will still pass. And it does. So with this, I can remove the threshold and the character named arguments here and just pass in that config that binds them together, that links them together, that in the darkness binds them. And then I don't think we need these thresholds anymore, although we do still need this to do. Oh, no, we do, because we're still referencing it down there. So let's put them back. And now let's update these conditionals to handle this config case as well. So the 10 config threshold, instead of accessing that constant directly, 5 config threshold, and still green. And see what I did? I went back and got things passing again in the test instead of moving ahead under red. Even if I was confident that I could fix things, it's just nice to have that green test coverage. So now I can remove these constants. In fact, ESLint is even telling me that it's not used, so that's very nice. Good suggestion for refactoring there. And things are still good. Things are still passing. So now we've extracted this handle threshold case function. And so now we've removed this duplication. Instead of these branches where we're doing duplicate logic, we are just doing a duplicate function call instead. And then that logic is in this one function in one place. So that's nice. All right, so let's commit this refactoring. We may do more refactoring now, but let's commit this refactoring because this seems like one good chance. And let me not hide this terminal again because it takes so long to get started. And so let's review our changes. We are adding in the function, and we could have committed the function, the one step of having the function pulled out and then changing to these config values, but we didn't. That's okay. Extract duplicate logic to function. That's a very general commit name, but it's good enough for now, I think. All right, so now you see there's still repetition here, where for the 10 config, we check if we're above or equal to the threshold, and if so, we call the function with that appropriate config. So even just the fact that we drill in here, use the config twice, further illustrates the repetition. And so this is where I think we're now ready for an array of these configs. And maybe once we have an array, we can finally think of a decent name for them. So I think we can just remove the duplication of these checks here. And I think we can take a small step towards it and actually get away from the names that mention the values as a first step. And so this is a numeral configs, maybe we can call it. And for these two cases, let's just say, it looks like we do the 10 first and then we do the 5. So let's put the 10 first and then the 5. And I'll just keep it here with the names in place already. And without removing them. And we can probably remove them later if we find that we need it. Oh, cannot access 10 config before initialization. So let's put it down below. All right, again, I'm making these small saves during these small refactors to make sure things are still passing. So now, instead of referencing 10 config and 5 config directly down here, let's reference them by index under numeral configs, because this suggests to us how we can move towards a loop in the future. Numeral configs, and it's interesting, right? Because like I have a solution in my head for where we're going, but I actually don't know how we're actually going to get there. And so this is not just a learning exercise. I'm really putting this in to help me visualize how we could do a loop to get us there. So let's replace 10 config with numeral configs 0, save and make sure it still passes, and then we can replace this config down here as well. I could have done it all at once, but small steps are so nice when you have these extremely fast unit tests running that can just confirm at any time the things are passing. And so here's another thing that I want to say about unit tests. When your code is not changing, the only thing that unit tests are really for is maybe regression safety. Well, there's other design things as well, but mostly they're there for regression safety. And so you can start to wonder, if my code's not breaking, why do I really need those unit tests? But when you're doing refactoring like this, where you're making lots and lots of changes to your function over time to move things around, to let abstractions emerge, to really optimally communicate, have the code describe itself and optimally communicate things in the simplest way possible, you're running these tests all the time, and they are showing you that your changes are safe and still working. So this is one of the big motivations for really thorough, extensive unit test coverage, is when you're doing this kind of refactoring, and to have the ability to do this kind of refactoring. So try it out. It's why I really encourage people to do TDD exercises to get a feel for it, because once you've gotten this type of flexibility, it's just the confidence you get is just so great for cases like this where I don't want to have to think about in advance how to come up with an algorithm to do Roman numerals. I want to let it emerge as we go. All right, so we've replaced all the direct references to these configs down below. So the only named references are here. So I'm just going to inline these now instead. Put the 5 config here, put the 10 config here, let Prettier deal with the formatting of it, save, and our code is still passing. So now this part of this to-do is handled. Our configs don't mention the values anymore. But we do still need a better name for configs. That name is still not great. So we now have numeral configs in an array for these different digits. And I've kept one out because it's sort of handled as a special case in a different way. So we can say here, and how do we do this? We look at these values. If it's here and if it's here, if, else. So how could we turn this into a loop? I'm thinking through. So it's really, now that we don't fall through, maybe we could put the return statement. I'll bet you if we had a for loop, we could return from inside of it. And then that way, if we fell out of the for loop, then we would be able to handle this else case with the 1 here. All right, so I have a picture of that. So to move towards that, I'm going to move the return statement into these blocks. This is again another refactoring. So now that this is the case, and actually the we don't even need the plus equals. Well, down here we do. In the one case, we do need the plus equals. But in these other cases, we can just return the call to that function. We save to make sure that's the case. Return call to that function. And now this numeral is not needed. So we save and we're good to go. So now this function only consists of the if, the else if, and the else. So I think now we can convert it to a loop. And I'm going to do that leaving these these explicit branches here and try to add a for in advance. For let I equals 0. And maybe a for each would work fine instead. I'm not positive. But I think a for statement, a for construct, is going to allow us to return early in a way that's kind of useful. And we can always change it up later once we get it working in the code. One of the great things about this refactoring, you can just code things in the way that the most easily occurs to you and change it up later. So I is less than numeral configs length, I plus equals 1. And so what happens when we have a numeral config here? Config equals, maybe we wouldn't even need the I. Maybe we could just go through the contents of it. I don't know. The point is we get the configs at that location, and then we say if, put a condition in here, if number, in fact, let me just do this. If it's greater than config threshold, then handle the threshold case with the config. So for the 0 case, we're going to see if it matches, if it's in the right range, we handle that case and return. Otherwise, we go to the loop to the next one, and then we fall through. And I think even though this should be handling these cases as well, I think our code will still pass when I just add in this for loop. So let me save and see if that's the case. It does. And so now that our loop is handling those cases, I think I can remove these branches one at a time. We don't need to hard code the 0 case because we've already handled it and returned. We save. And then we don't need to handle the 5 case because we've already handled that and return. And so then I think we can just, we don't even need the else here. We can just have this, the 1 case, a lot of comment there. And we save. And we've returned. So this is great. We've now changed a series of if-else statements into a loop of these configs. So what was duplicated code has now become config, where all that differs is these configured values between them. So that's pretty cool. That's pretty exciting. This handle threshold case is now the code that will handle whatever case we have, and we can go through it. And then we have our for loop here where we go through them all. So let me commit this, and then let me try to kind of talk through it since I've been stumbling through this myself and figuring it out as we go. So we got the numeral configs. We've got our if-else replaced with a loop. And we'll commit this and say if-else loop for different characters. So yeah, what happens in number to Roman numeral? And let's just walk through the sequence to see if we can understand why this happens. So for number to Roman numeral, we go through the configs, and let me split this. So here's our configs. So we say, okay, I've got a number coming in. Any one of these numbers, I need to convert it to a Roman numeral. And so starting from the highest digit first, we say, okay, is the number greater than the threshold for it, that digit minus 1? And if so, we want to handle that case with some code here where we potentially put a 1 in front of it. I think that's going to need to be dynamic in the future, incidentally. And then we add the character itself, and then we recursively call down for the remainder. And this is why I think we can just return directly from here. We don't need to kind of keep falling through in the call to number to Roman numeral itself, because we've recursively called it here, and the process starts all over. So if it's above the 10, we handle it with the X. If it's above 5, we handle it with the V. And then if not, for the remainder, for the 1 case, we just have the numeral and we add it up and then return it. And you know what? I think this could actually get simpler here as well. No, I still didn't know how to most easily get the number of ones that correspond to the number. So this is probably fine for now. Okay, I don't know if that's a good explanation, but this isn't a class, this is a live stream, and I'm figuring this out along with you. So I think we're good. We're going to move on. We're at 5:30, and we've made good progress. I mean, this was the kind of abstraction that I was hoping would come out of this. And now let's see with the other cases how things fall out of it. Let's go back to our test. We can remove that tab there. I'm just going to copy and paste this time because these things are so similar. Converts 13 to XIII, a very nice Final Fantasy game in the series. We save, and actually the test has passed already because the abstraction that we went to, where we were calling through for those remainder digits, calling their number to Roman numeral, was actually already handling the III case for us. So that's very nice. So now we start to get to the point where we say, do we want this test case in here for coverage, or do we want to skip over it? And just for the sake of showing a different approach, let's not add the test in. One approach that can be taken to TDD is, if the new test you put in already passes, then you know what? That's already specified by your test, and you don't need to cover it. We can just move on from there. So let's go on to 14 should be XIV. Let me see if this is described in our initial exercise here. They said reference website for Roman numerals. Numbers in the teens, 20s, and 30s follow the same form as the first set with X's. So this is not making it super explicit, but we do, like 14 is XIV, as fans of the online Final Fantasy will know. So let's see if this will pass. And I think based on our kind of recursive calling of stuff, I think it will, because I think we're going to get the X, and then the remainder is sent back to number to Roman numeral, and I think we're going to get at the IV from that recursive call. So I'll bet you this will pass already. It does. Well, so let's see if 15 as XV is going to pass, and I think it will. All right, that's great. 16 XVI, just to make 100% sure. I think it will pass, and it does. So let's go up to 19 is the next kind of unique case. XIX. 19 is XIX. I don't know if this is going to pass. Let's see. I think because it recursively calls through, it can match an X case again. So I think this will actually pass. And it does. I think it would be good to show... I don't know, just subjectively, it feels good to have the 19 case in there. And I think I'll do a 20 as well, because that's where we get the multiple X digits, just to show, just to demonstrate that that is looping and happening there. XX. So where do we go up from here? XXI should be fine. What is the next digit? L means 50. I'll bet you can figure out what 40 is. If you guessed XL, you're right. 10 subtracted from 50. So 39, let's do 39 first because it's the last normal case before that. 39 should be XXXIX. I think that's the case. Maybe I'll check that out sometime later to make sure that's the case. Fans of football will know if this is the case or not because of the big game. He Who Should Not Be Named, which I make fun of every year. A lot of us do, a lot of us non-sports nerds. All right, 39 is XXXIX. Next is, our next unique case, I believe, is 40, is XL. So 10 before 50. I mean, we don't have an L being outputted, so there's no way this is going to pass. I don't know how badly it's going to fail, but that's okay. We're going to find out. So again, I kept a few cases in here that were already passing. Oh, you know what? And let me just commit those. Just because that feels like a nice, good chunk. I subjectively decided that those cases were good to handle. And we can even see over here that Roman numerals did not change as a part of this. Add tests for already passing tests for unique cases. We just add them in for regression coverage. And now we add in the 40, which I'm sure is not going to fail. So we're now back to our TDD loop, red-green refactor. This test will be red. It will fail. Instead of XL, it gave us XXXX. So we see now that at the 10 digit, we're following the same pattern as in the I case, where it's just repeating indefinitely, and we don't want to go there. We want to handle this special case instead. We've got to figure out a way to do it. And I think these patterns that we've been seeing emerge in the production code are going to continue to emerge as we just handle this approach of red, we've got the test to fail. Now we're going to go to green to get it passed in the simplest way possible and let abstractions emerge from there. Again, if anyone has joined us a bit later, please feel free to say hello in the chat. Love to hear from you if you like, and where you're from and what you're up to. Thank you for joining. And I see someone joined just before I said that. Robin Malfate said, hey, have you tried jest with it.each? That's pretty interesting for these repeating patterns. That's a great suggestion, Robin. I have not actually done that. I've known about other test frameworks that have done, provide you some way when your tests are just identical, like it's just a different input and different output. So let's look that up real quick, and if maybe we can get to that a bit later in our next step here. It.each. I have not heard of this before. It, also known as test.each. If you keep duplicating the same test with different data, which is exactly what we're doing here, allows you to write the test once and pass data in. Example. Add, and so you can give it a name, I guess, and it fills it in. All right, cool. This seems really good. This seems perfect for this because I was feeling like this is too repetitive. It, like at this point, the repetition doesn't actually help you see it. It's just so repetitive, it would just make it tedious to see. So I'm going to check out test.each offline, or it.each, and see how it goes. I'm sure it's going to work great. I just can't quite think through it at the time. So yeah, this seems great. Robin, thank you so much for that suggestion. I really appreciate it. That's a great one. And I'm going to post it. The link here. And there's the docs for it.each. Much appreciated. Anybody else in the chat who's here, please say hello and let me know that you're here if you like. I'm just glad that folks are here and joining in. All right, cool. So it.each is a great suggestion. All right, so we've got our 40 case failing here. So let's think about the state of our code and what we should do. We could think ahead to adding another config for it, but I think that's a little bit ahead of the game. So let me add just another conditional here to build this up a bit more. If number equals 40, return XL. And I think this is the simplest way to pass the test. I am Noah, or Lamb Noah. I can't tell from the capitalization from the font. I am Noah, or Lamb Noah 99 says hello. Hello, I am or Lamb Noah. I'm glad you're here. All right, we saved the test here and it passes, so that's fine. Do we want to refactor yet? I think I want to add a few more test cases because it's just very easy to see them coming. That's going to help us see exactly how this abstraction should fit in with what we already have. So let's add a 41 case. 41 to XLI. The need for that each is becoming very clear here, so I'm going to be glad to look into that on my own. Instead of XLI, we have XXXXI, so that's not what we want. So what is happening here? We've got XL, and then the I is being added onto it. So let's just say let numeral equals XL, turn numeral, and then here we say numeral plus equals number to Roman numeral, number minus 40. So I think this is going to get an I or multiple I's onto there. It does not. But we want to say if this number is greater than or equal to 40. And then it passes, so that's great. I'll bet you our 42 case is going to pass as well. I bet you we have that covered. XLII, 42 XLII. We save it, and it does pass. That's great. So is this yet? So let's talk about refactoring. And let me commit these because the refactoring could be significant. We say handle 41 and 42 cases. So what is this identical to what we have above for the threshold case here? I'm not sure that it is yet because we don't have the numeral 1 coming into there. Let's go up to the 50 case because I think the 50 case is going to help. I'm pretty sure 49 is going to work, so I'm going to put in 49 just to show it. XLIX, 49 XLIX, and that is covered. Let's commit that. Show 49 case working. The 50 case feels like it's going to start to add code in a similar shape to what we've seen before. So let's add a 50 case. 50 should be L. So this is certainly not going to pass. Nope, we get XLX. So 10 before 50 and then add 10 in. So that's not what we want. We want that to be 50. So we can add in a conditional here. If number equals 50, turn L, else if number greater than or equal to 40. I think this will pass the test. Obviously, it's fairly obvious that this is not what we're going to want, but let's just commit it. Handle 50 case. So now let's think about refactoring. If number is equal to 50, so this is going to start to look similar to here. So instead of duplicating L here and XL here, so L here and L here, I think what we can say is if number is greater than or equal to 40, let's move this condition into here. We save and it still passes. And now let's build it up instead. Let's build up the numeral. Hang on a second here. XL. Okay, cool. This is starting to stretch my brain here to figure out how to handle this case. Number is equal to 50, then L. So let's say if number is less than 50, numeral plus equals X. And then we numeral plus equal. This is probably too many changes at once. Numeral equals. I think I've taken too big of a step here. I'll bet you the test will fail when I save it, and sure enough it does. So let's just undo that. Go back to when it was passing and think about it in smaller steps. Again, it's nice. I don't need to keep going down a path of more and more red. I can kind of think through it. So let's get that to move more slowly towards where we are. Let's say let numeral equals empty string. And here numeral plus equals L. Return numeral. And then move here plus equal XL. Save and this passes. So how can we shift this around some more? We do have a return statement here, and I'd like to get to the point where there's a single return statement. So how can we do that? We're going around here figuring out like what exactly happens with these numbers and when do certain things happen. So this all happens when we're in the 40 range, the 40 case. It's not a special case here of 50. L is always added in. So let's actually go down here. Let's say plus equal to X and then plus equal to L, because this gets this duplication to this more similar. So really, this is actually if number is not equal to 50, we add in the X and then the L. And you know, at this point, I'll bet you don't need this return statement here because I bet it's okay to fall through to here. Nope, it's not. LX. So let me go back. Oh, you know what? L is added here, and then for those 40 cases, the L. So hang on a second here. If a number is 50, we add L. If the number is not 50, we add X and L. So you know what? I'll bet you I can move this down to here. And it passes. Can I remove that return statement? Nope. XL, XL. So I think what's happening is, that return statement's killing me. Why does this return statement? What's happening? Y'all watching the stream or recording could probably see it better than me. If the number is not 50, add XL. If it is 50, add L. Oh, it's because number minus 40. That recursive call is a problem. So let's put that around a condition around that. If number is not equal to 50, and then we recursively call down. Again, this is all very messy. None of this I don't think is going to stay permanently. We're just gradually moving towards the point where the patterns will emerge. We save and this is fine. Now that there's a conditional here, I'll bet you I can finally remove this return statement. And it passes. So check out what we have here. If number is not 50, add X and then L. And if it is 50, add L. I think what we're saying is just that we are always adding L. And that's what we've gotten down to. All right, so yeah, if number is greater than 40, start out, add X if it's not 50, and then always add L. And then if it's not 50, call down recursively to what's remaining. So this is starting to look much closer to this. But the note here, we are adding an X instead of a 1. So I think there's a repeated concept there. Let's start to move this code towards this config concept, the threshold and character. And we can do that easily just by creating some constants up here. I think the threshold is 40. It's not quite the same because there's just a -1 here. So let's let's hold off on doing too much here. Number is greater than, no, it's threshold. But then there's the 50 there. I think the threshold is 50. And so I think if number is not equal to 50, let's just save one step at a time and make sure this is good. Threshold minus 10 for some reason. And then threshold minus 10. Nope, that was not right. Number minus 40. Why can't I do number minus threshold minus 10? That seems like that would work. That's very strange to me. Why would that be? Maybe an order of precedence or something? Oh, yeah. That's right. Number minus threshold minus 10. I actually want number minus threshold plus 10, which is to say I want to subtract 10 from the threshold to get it down to 40 and then subtract it that way. Again, if you were changing so much at once, that would be very confusing, but by taking small steps, I'm able to move more closely towards it. So what is the 10? Let's give it a very silly variable name. 10. Is it a step down? Yeah, there's some kind of concept that's going to emerge from here. So let's go ahead and make this in terms of one of these configs, not included in the list. We'll say 50 config. Threshold equals 50. The character is L. And so let's use this. Threshold const threshold character equals 50 config. And the character is added in here. All right, so the other things, so we're getting closer to having this fit the handle threshold case loop. But one of the things that's different here is we're stepping down by 10 instead of by 1, and then the digit we're adding is X instead of 1. So there's a pattern there. And I'm not quite sure how to look up that recursive config yet, but I want to give it a name, and we'll put it in, and then we'll let that emerge later as well. So there's a threshold and character, and then we could say maybe this is a step down amount. Name is not good. And step down character equals I. So when we need to step down from 50, we go down by 10 and we put the character, the character X. to do it. I don't know, that's something that kind of stick in my head. Step down amount, step down character. So now instead of 10, this is the step down amount. And this is the step down character. And that all passes. So this is interesting. So now let's go up here and let's add step down amount and step down character to these other cases as well. And what they are in both cases is down by 1 and character I, down by 1, character I. So that's duplication. I'm hoping that'll be able to go away, but we don't need to go there yet. We can take small steps towards it. So let's now pull out step down amount and step down character up here. We're going to let the code tell us and show us how to use these things. Here's the step down amount. And here's the step down character. We save, and our code works. So this is a very interesting refactoring. This case now, this 50 case, is now being handled. Robin says, now I want to implement this myself, lol. Please do it. It's a great exercise. I've not gotten this far, I don't think, in the exercise, and there's a long way to go. We're not going to finish today, unfortunately. I'll paste it again in case it's not visible in the chat history, JSTDD Numerals. Give it a try in JavaScript or in some other language. It's been a really fun exercise. And again, one of the reasons I chose this exercise is that I know it's very helpful to see the benefit of building things out one step at a time, because I would not want to think ahead to implement this algorithm from the get-go. So now this whole 50 section here is very similar to handle threshold case, to the point that I think we might be able to just add in the 50 config into here. This is not going to be hit because of our previous condition here. So what happens if we just comment this out? I think this might work. This would be a great point to end on if it does. It does not. XLIX is L. How many cases failed? 40 and up. So we're not detecting the 40 cases correctly. So there is something different. So let me see here. Oh, you know what? It's what we're detecting here. We're saying if number is greater than the threshold minus 1. So this 1 should be a dynamic thing as well. So let's pull this out. Threshold and step down amount. Pull this out of config. And we're just going to do threshold minus step down amount. This should still pass. And so now I bet if we comment out this section, maybe it's working. I think this is still different. No, so let's look at that for a second there. Here recursive, well, let me save again to make sure we're still green. Here where we go down, in the 50 case, where we recursively call down number to Roman numeral, we take the number minus threshold minus step down amount. Here we just go down by threshold. We don't subtract that step down amount of 1. Why is that? I don't know. Step down amount in the case of 50 here is 10. 40. If number is greater than 40, then call down number minus 40. If number is greater than numbers equals, that's equal. Yeah, so something is different. I want to just switch over to this. This has been enough refactoring that I think I want to go ahead and commit this as we are here. So we added the 50 config. So this is express 50 case in terms of a config, not yet in the loop. Seems to be a way to capture what we're saying. So why do we go down by the threshold here? Oh yeah, what I was going to do is I want to comment this out to see what exactly fails now. When we say, hey, I just want the 50 case to be in the loop, show me. Now it's 40 is handled, but 41, 42, and 49 are not. XLI goes to L. XLII goes to L. XLIX goes to L. So this is helpful. So I think this is a condition that's too specific. And maybe we can get it working from this red state here. So we're saying for 41, it needs to be XLI. It needs to not go up to L. So up here, we need to not say... Oof, yeah, this is so abstract now that it's hard for me to follow. I don't think that means we've done it wrong. Just interesting to think about. There might be a smaller step way to get there. So let's see if I can get there in the next few minutes. Threshold minus step down. If it's equal to 40, add that in. I think it needs to not be equal to 40. So yeah, so 40 cases handled, XL, that's fine. I think it's if it's the number, and let's compare to this. If the number is greater than equal to, if the number is not equal to the threshold. I wonder if we say if the number is not equal to the threshold. We're not looking at step down amount. Maybe that's not needed. I bet it's needed. I bet we're going to break more stuff now. We broke a bunch of stuff there. So that doesn't seem like that's going to be productive to go that route. Man, I don't know if I can pull this off in the next couple minutes. So there's some difference. Let's zoom back up. I think I'm not going to be able to solve this right now, but we can see where we are here. And I can even just leave this commented and say, to do, what is different between the chunk below and handle threshold case? Why does case 40 pass and 41 and up fail? So this is a to-do. We can kind of save this to-do to commit in this red state. Commit with failing tests under failed refactor. Yeah, so this is our current state of our learning. So we got to the point, and I think we're going to call it, I think we're not going to revisit this again next week. We're going to do something new. But we got to the point where we got these numeral configs, the 10 config and the 5 config, and we saw this pattern of 10, of a threshold and a character, started to see a step down amount and a step down character. And so we got to the point where we had a single function that implemented the functionality for both of those cases, the 10 case and the 5 case. But then we did not quite get there with the 50. Something was different about the 50. So that when we have it hard-coded for the 50 to be handled differently, our tests are passing. But when we try to use this same function, there's something different. There's something not quite the same. And I think it has to do with the 10 versus the 1. The fact that the step-down amount is by 10 versus by 1. So this is challenging. I might do this on the side to try to make more progress. Because it's frustrating. And I feel like maybe if you got there, maybe this is the way these things always work, but maybe if we got there where we got a function that handled the next case, the 50 case, maybe everything else would fall out from that and we'd be done. I think that's what I need to tell myself to encourage me to try this on the side to try to get there. But this is where we're going to leave it. We're going to leave the code here. I'm going to go ahead and push it up now so you can see it if you want to give it a try. At that link, the JS TDD Numerals link that I shared in the chat, and it's going to be... comment it out. Let's push it up. I will update it and get it working in the repo if I do, in fact, go back to revisit it so folks can check it out from there. But the ultimate point is not to see the solution. It's actually kind of better not to see the solution, but to go through the exercises yourself. So I would really encourage you, in JavaScript or in another language, do the Roman numerals kata. Check it out at codingdojo.org. Thank you so much to Coding Dojo again for pushing this up. All right, so our next stream is going to be next week, Tuesday, January 12th at 5 p.m. Eastern again, and we're going to do a new project. I'll let you know what it is. Just a very quick teaser. It's something that I've started test driving a few times in the past, and it's a really good fit for test driving because I don't know how I want to implement it, but it's a real thing, real code that I would like to have. It's related to a kind of natural language parsing-ish, We're not doing machine learning, artificial intelligence, anything like that, but I want to be able to write something kind of like natural language to describe objects in relationships with properties and things like that. If you've ever played the adventure game Myst, that series, M-Y-S-T, it's related to that. The idea from the books behind it of being able to write these words and have a world created in response. So I want to be able to write words and have a computer interpret them to see, oh, I get what you're saying. You're saying there's a big red dog. You're saying there's a small blue ball. And I understand what that means. And so we're going to try to write a kind of natural language parser to handle this language and turn it into a data structure that you could use to render out a 3D scene or something like that. So Tuesday, January 12th, 5 p.m., please join for that or check out the recording afterwards. If you want to follow me, you can check out codingitwrong.com. You can see quick links to my Twitter, Twitch, YouTube, blog where I blog about programming. I'd love to connect with you in any of those places that you would like. Please reach out to me on any of them and say hello. Let me know your thoughts. Any questions you have about testing. I love talking about testing in TDD and just sharing thoughts on that. You can send me questions, ideas for things you'd like to see me TDD, and maybe we could do those in the future sometime. I'll share again Outside In Front-End Development, my free online book. No strings attached, nowhere to sign up. Just check it out at outsideindev for a description of a TDD workflow you can use for front-end apps like React or Vue.js applications. Would love for you to check it out and see if it's useful. So that's it for today. Thanks to the folks who joined, JCubed, Robin, I Am or Lamb Noah. Thank you all so much for chatting, and I appreciate the folks who comment in and follow in YouTube, who leave encouraging comments on YouTube or tweet out about things. Makes me feel good, makes me feel like this is time well spent. So thank you for doing that. Please send encouragement along if you like. Please share this with your friends if you found it useful, and I hope that I can be helpful, just one small step on your journey towards growing as a tester. So thanks so much, have a great week, and we'll see you next week. See ya.